Hello everyone, I remain your tutor Mr. Life Changer. Here is a part 4 series of calculations on heat, energy, heat capacity, latent heat. In this video we are focusing on latent heat. Okay, so here is latent heat. Let me give you a background before we continue. Latent heat is the heat involved during a phase change. What we mean by phase change, when a substance, a phase change is that period where a substance changes its phase, maybe from solid to liquid or from liquid to gas, and any of that. Okay, and that type of heat involved during phase change is called latent heat. And I want to say something here, that during phase change the temperature does not change. During a phase change, temperature does not change, and that's the reason why latent heat has the formula ml. Okay, M stands for mass, L stands for specific latent heat. L is specific latent heat. Okay, so anytime there is a change in temperature, heat is simply mc theta. But when there is no change in temperature, only a phase change, that process where ice is melting to water or water is freezing to ice, or that period, that process where steam is converting to water or water is converting to steam, that is what we call the phase change, and the heat involved during that is called latent heat. And we have two types of latent heat. We have latent heat of vaporization, we call it vaporization, and we have latent heat of fusion. Okay, so latent heat of fusion is between solid and liquid, the phase change between solid and liquid, either liquid converting to solid or solid converting to liquid. But latent heat of vaporization is between liquid and steam and gas. Okay, so that's, or gas to steam. That's very important for us to know. So let's see some questions here. Now this one says, how much heat is required to melt 500 grams of ice at 0 degrees Celsius? And we are given the specific latent heat of fusion of ice to be this. Okay, ice has a specific latent heat of fusion. Now if you notice the word melt, that means there is a phase change. Those are this kind of statement: melt, freeze, vaporize, condense. Those are phase changes. And in that case now, the latent heat, the heat involved is simply ml. I can say mlf since this is specific latent heat of fusion. So the mass here is 500 grams, which is 0.5 kilograms by conversion. Then multiply by this, which is 336,000. And by the time we divide, we are going to have 6 and 8. I guess 168,000 joules. So the answer is A. Okay, so the next one is says a 200 watt electric heater melts a block of ice in 14 minutes without any temperature change. Of course, during that process of melting, there will be no temperature change. Don't forget that. That's an exam question. What is the mass of the ice melted? Okay, so in this case now, electricity is used to melt the ice. Since we are given power and we are given time, we can just say power times time is equal to ml. The heat involved here is just for melting, so it's a latent heat. So the power here is 200, the time is 14 minutes, which is 14 times 60, equal to ml. The mass is what we are looking for. Specific heat capacity is 336,000. Okay, so I guess we should use calculator here. I have calculator here. So let's say we have 200 times 14 times 60, and that is 168,000, now equal to 336,000 m. So if I divide both sides by 336,000, m is going to be 0.5. So 0.5 kg is the answer to this question. Quite easy, right? Now the next question says 300 grams of ice at 0 degrees Celsius are added to 500 grams of water at 60 degrees Celsius. This is mixture, method of mixture. How much of ice melts? Now remember, ice melts at 0 degrees Celsius. It's already at 0 degrees Celsius. If it was not at 0 degrees Celsius, it won't melt yet. That means it's possible for ice to be at minus 20 degrees Celsius, minus 10 degrees Celsius. At those temperatures, it is not going to melt. It is only going to melt once it is 0 degrees Celsius. Kindly note that. And we are going to see questions relating to that as we continue. So after adding this to this, how much ice melts? In this case now, it's going to be that in this case, ice is the colder body, so ice gain heat. So I'm going to say heat loss by water, because water is losing heat. 60 degrees and 0 degrees is going to be equal to heat gained by ice. Ice is what is gaining heat. Okay, so the heat loss by water is simply mc theta in this case, and the heat gained by ice is also, oh no, in this case now it's going to be ml, because if you notice, the heat energy supplied was just enough to melt the ice. There was no change in temperature, so we use ml. Please don't forget this. The only time you use mc theta is when there is a change in temperature. But when there is no change in temperature, there is only a change of phase. Temperature does not change. We use ml. I hope that makes sense. So this is for water. Let me call it m1 c1 theta 1 to differentiate them. This is m2. So this is the mass of the water. The mass of the water is 500 grams, which is 0.5 if you do that. Then specific heat capacity of water is constant, is 4200. Then times the temperature change of water. The water was at this temperature. Oh, we are not given the temperature change of, we don't know the temperature of the mixture. Okay, how much of ice melts? So that means the final temperature is still 0 degrees Celsius, because it was only enough to melt the ice. There was no the temperature did not go enough. I hope you understand that. So this is going to be 60 minus temperature of mixture now is still 0, because when ice melts, the temperature does not change. It still remains 0 degrees Celsius, and that's exactly what this is saying. So the temperature change, this is supposed to be theta 1 minus theta m minus the temperature of the mixture, just that the temperature of the mixture is still at 0 degrees Celsius. Now the mass of ice is what we are looking for. Specific latent heat of fusion of ice is 336000. So if we multiply this is going to give us, let's say, 2100 times 60. This is going to give us 126,000 equal to 336000 m2. So the m2 now is going to be 126,000 divided by 336000. So the answer to that is 0.375 kilogram, which means 375 grams. Now let's see what option will be the answer. So what that means is that the heat lost by water can melt 375 grams of ice. Are you seeing that? So the correct answer to this question is that all 300 grams of the ice melts, because it's not even up to 375 grams. So that is exactly what we have here. All of it melted, and because the mass of the ice is 300 grams, but based on our calculation here, the amount of ice that this can melt is 375. I hope that makes sense. Another way you can answer this question, if you don't want to go about it this way, you can substitute the value for m2 here. That means you can calculate the heat loss by water. Heat loss is already 126,000 joules, and you calculate the heat gained by ice. The heat gained by ice is the mass of ice here is 300 grams, which is 0.3 multiplied by 336,000. Let me multiply that. Okay, so this is giving us 100,800. So you can see this is the amount of heat available of the hot. This is the amount of heat that can melt the ice. Are you seeing that this is already greater than this? So this is also an indication that all of the ice melts. I hope you understand this, because for the ice to melt, heat loss should be equal to heat gain. But in this case, heat loss is even greater than heat gain. That means all the ice will melt, and even more, there will be more increment in temperature. So please, that is how you go about that. Now the next question says that the specific latent heat of fusion of a substance is 2.4 times 10 raised to power 5 joules per kg. What mass of the substance can be melted by 48,000 joules of heat? This is quite easy, because heat is equal to ml, simple. So we are looking for mass. That means mass is going to be heat over L, right? Because that's what we are looking for. It says what mass? Okay, so heat over L. So the heat here, H, is 48,000 based on the question. Then the L, the latent heat, is 2.4 times 10 raised to power 5. Okay, if I know my maths well, this should be 2 times 10 to the power minus 1. That's 0.2 kilograms. So the answer is B to this question. I hope that makes sense. Okay, then this one has to do with latent heat of vaporization, but still the same thing, but just that this one has to do with steam. How much heat is needed to convert 0.5 grams of water at 100 degrees Celsius to steam at 100 degrees Celsius? Since there is no temperature change, water at 100 degrees Celsius, steam at 100 degrees Celsius, the only heat involved there is just ml. No temperature change, just ml. Okay, so the mass of water is 0.4. The latent heat is 2.26 times 10 raised to power 6. And I guess that gives us 9.04 times 10 to the power 5. That's the answer to that question, joules. B. Okay, quite straightforward. Now the next one says a heater of 500 watts is used to boil water. If 0.4 kilogram of water evaporates per minute, that means every minute you have 0.04 kilogram of water evaporating per minute. What is the specific latent heat of vaporization of water? Now in this case, now you use the heater to boil water. So this is a case of using electrical energy to heat. So I'm going to use power times time, okay, equal to ml in this case, since it is just enough to boil the water. He said if 0.04 kilogram of water evaporates, that's the vaporization. So PT equal to ml, but this L now is V, latent heat of vaporization. The power is 500. The time is per minute. Per minute means 60 seconds. So 1 times 60. The mass is what? The mass is 0.04. And the latent heat of vaporization is what we are looking for. So LV is going to be 500 times 60 divided by 0.04. I think that is, let me do that quickly with my calculator here. Okay, so this is 750,000. 750,000 joules per kilogram, which is A. Makes a lot of sense, I guess. Okay, so this one says 5 grams of steam at 100 degrees Celsius is passed into 95 grams of water at 20 degrees Celsius. What is the final temperature of the mixture? Very interesting. Now, since there is a temperature of mixture, we are going to still use the formula we are used to: heat loss equal to heat gain. But now let's be careful. What is losing heat? The steam is losing heat. And what is gaining heat? Water is gaining heat. What is the heat loss by water? First of all, the steam will be converted to water. This is the transformation. You have steam at 100 degrees Celsius must be transformed to water at 100 degrees Celsius first, before it now transforms to water at that temperature of mixture, because that's what we're looking for, the temperature of mixture. And this first transformation is ml. The second transformation is mc theta, because there is a change in temperature. But when steam is changing to water, temperature didn't change, and that must happen before the temperature now increases again, or decreases, So I'm going to come here and say ml plus mc theta. Then the heat gained by water is simply mc theta, nothing changed. So I can use here m1 because it's the same steam. When steam changes to water, the mass remains the same, the mass does not change. Okay, so this is water, so specific capacity of water is the same thing. Let me call this m2. Let me call this temperature change should be theta 1 minus theta m, because there is a temperature. This reduced from 0 to the temperature of mixture, and why this one should be theta m minus theta. Okay, if you are watching this, I expect that you have watched my previous video. That's the only way you can understand this. So as long as there is a heat loss, it is mt theta 1 minus theta m. That means the higher temperature minus the temperature of mixture. Then here you are going to have the temperature of mixture minus the lower temperature. Kindly note that. So here the mass of the steam is 5 grams. Okay, so I'm going to convert it to kilogram, which is 0.005, I guess, times the latent heat is 226,000. Then plus the mass of water now is still the same 0.005 because it has changed. It's the same thing. Specific capacity is 4,200. Then times the temperature change for this guy is, initial temperature was 100 minus the temperature of mixture. We don't know what that is. So this is equal to, the mass of the water is 95 grams, which is 0.095. The specific capacity of water is 4,200. The temperature change is the temperature of mixture minus the temperature of water. The water was initially at 20 degrees Celsius. Okay? So if we are to use a calculation, let me use my calculator here. Okay, this is, the first one is giving me 11,300 plus this times this. This is 2100 minus theta m is equal to this one. Okay, this is 399 into theta m minus 20. Okay, so let's open a bracket. This is 11,300 plus, if I open this bracket, this is 2100 plus 21, okay, minus 21 theta m is equal to, this is 399 theta m minus, I guess this is going to be 798 0. So if you collect like terms, it will be 11,300 plus 2,100 plus 7,980. If this crosses over, is going to be equal to 399 theta m plus 21 theta m. Okay, hope that makes sense. So if we use our calculator to do that, 11,300 plus 2,100 plus 7,980, this is going to be, and please don't be scared, I'm just teaching you this. The exam doesn't have to be this tough. Okay, so don't be scared, just learn. This is 420 theta m, so theta m now is going to be 21,380 divided by 420. Except for those of you that will be writing, theory questions, you will need this. So I'm getting 50.9 degrees. So is there any 50.9 here? Okay, there is no 50.9. So it is either I made mistake somewhere or that, but I don't have that time to check that. It's just to show you how to go about this. So this is that. Then the last question here says, how many minutes does a 1500 watt heater take to completely evaporate 0.3 kilogram of water already at its boiling point? Okay, so power times time equal to ml as usual. So the power here is 1500. We want to find time. The mass here is 0.3. Latent heat is 2.26 times 10 raised to power 6. So the time is going to be 0.3 times 2.26 times 10 to the power 6 divided by 1500, and that is going to be 0.3 times 2.26 times 10 to the power 6 then divided by 1500. This is giving me 452 seconds. If I want to convert this to minutes, I'll have to divide it. 452 divided by 60, right? So let's see that. 452 divided by 60 gives us approximately 7.53 minutes. So the answer to this question is A. Okay, so thank you very much. Kindly share my video, kindly comment, kindly follow, because it is back to back. The videos are coming back to back. Have a nice day. Thank you. See you in my next video. This is not all. There's one more. See you in my next video.